Well, hello everyone. My name is Jacob Harvey, and I'll be giving the guest lecture for today's NRM 1401 lecture called Food, Fiber, and Feed. How do we sustainably harvest resources from our landscapes? We're going to be discussing some of the history and concepts of agricultural practices in the Great Plains, as well as some of the strategies used to conserve those natural resources. So I just wanted to give a quick introduction about myself. I graduated from Texas Tech with my master's degree back in December of 2022. I've stepped into a position with the University of Nebraska up in the Sandhills, serving as a research coordinator for the Barter Brothers Ranch. The ranch itself is roughly 5,500 acres of contiguous grassland used by the university for research in both agricultural practices, so with livestock production, but also within natural resources. So we're talking everything from grassland plants to wildlife to soils. The long-term plant collection data that's been going on out here stretches all the way back to 1998 when the ranch was first acquired by the university, and is currently the longest running plant data set for UNL range folks. So it's pretty cool to be out here. I'm talking to you roughly 600 miles away from Goddard. We're up here in the northern central portion of the state of Nebraska. And a couple questions looking at this map here on the right is I just wanted to ask you guys, what do you notice about the landscape within this aerial imagery? Well, for me, looking from east to west, we can see how green it is on the eastern side of all of these states within the Great Plains to how brown it gets once you approach the Colorado Rockies Front Range, right? And that's just a stark reminder of the precipitation gradient that runs east to west through the Great Plains that affects not only the plant communities here, but also how we need to manage our natural resources in these areas. So going from there, I just wanted to give you a brief outline for today's lecture. We'll be starting with crops, moving over into our livestock on rangelands. We'll briefly touch on the timber harvest here within the United States, and then kind of wrapping things up from production agriculture, we'll then touch base on soil health and rangeland management. Colonists brought their styles of farming from Europe, and we were able to combine this with the traditional knowledge from Native Americans to begin farming practices across the United States. The Atlantic slave trade really represents the largest shift in agriculture styles within the U.S. that shifted a lot of practices from more of our subsistence farming, so you grow what you eat, to large wealthy plantations in the American South where agriculture was the big business in the area, and rather than growing food, they were growing fiber and tobacco for purposes other than just feeding their families. The Industrial Revolution then was able to bring about many of the cultural changes to agriculture, such as bringing in the moldboard plow, introduction of tractors, etc., to really revolutionize the style. In the 1930s, the Dust Bowl was revealing the biggest problems with continuous cropping and intensive tillage. So these basic agricultural practices being done across the U.S. ended up wreaking havoc within the western Kansas, Oklahoma Panhandle, and northern Texas region of the U.S. With that, brought a new understanding of soil conservation through a gentleman by the name of Hugh Hammond Bennett. The Soil Conservation Act was passed in 1935, which created the Soil Conservation Service, within the USDA, which now is rebranded as the NRCS, so Natural Resources Conservation Service. Many towns and counties have NRCS offices within them, and that was all because of the response to the Dust Bowl back in the 30s. So that brings us into modern farming techniques. So cropping, we're going to talk a little bit about cropping systems. So as I mentioned earlier with the Dust Bowl, the major cause of the Dust Bowl was through continuous cropping. And this is when the same crop is planted in the same field year after year. Because of that same cropping and same intensive tillage practices within those fields, the soil gets worn down and depletes the area of nutrients. A practice brought originally in by Native Americans and introduced to European farmers was rotational cropping, which is using different crops in a field as long as they're alternating those crops with no consecutive years of the same crop in the same field. That way, these different crops are able to take in different levels of nutrients as well as impact the soil a little bit differently. That allows for conservation of that soil profile to last longer. So moving on from rotational cropping systems, we have strip and cover crops. Strip is intermixing those crops in the same field, and then you can mix your harvest and planting times. We do this mixing harvest and planting times to save resources on labor, as well as to be able to hit the market at multiple times per year, as well as keep those crops safer from pests and damage. If you have one type of crop in one field, all of a sudden you have one pest that comes through and takes out only corn, then your whole field is gone. If you are able to strip crop, that pest might take out the corn, but you still can have some type of profit from that field. Cover crops, you have no intentions of making a profit off of these crops. These crops are more like basic plants that are there to just cover the surface of your field, as well as conserve your soil. However, they might be used for grazing, but for the most part, they're not harvested for any profit. Alongside our cropping systems, we can also adjust our planting styles to allow for better conservation within our fields. Terracing is the act of reducing downhill erosion by grading your areas and then planting along the grade. Contouring is similar to terracing, it's just not done on such a steep slope, but you're planting along the contours of your field, which is slowing the downhill flow of water. We can also adjust our tillage practices to make conservation more apparent within our fields. Conventional tillage is what is seen a lot of times out around Lubbock. You've got continuous cotton with conventional tillage. That's why your guys' sky turns brown within the spring when the winds pick up. This conventional tillage is leaving less than 15% residue, mostly serving to break up the ground and get rid of last year's past crops that you can plant directly back into that soil. Conservation tillage is a practice in which you want to leave at least 30% residue within your field. That is done to reduce your wind erosion, yet still be able to break up the soil surface. And then no-till is done with 100% residue. You're not allowed to do any tillage in that area to be considered no-till. And that's when you're keeping your tiller out of the field. You're never disking anything, and you're just seeding directly into your field and the organic matter from last year's crop. Water management is also done within the Great Plains to a varying degree because of our precipitation gradient. In areas where you see higher rain, or possibly even areas that are more drought struck, and with irrigation laws set in place, you'll see more of your dryland cropping, which is not allowing for any irrigation. A lot of times, though, within the Great Plains, we'll see this well irrigation style of irrigating our crops from a drilled well with either laid pipe or pivots. The Ogallala Aquifer is this resource that we're tapping into in order to get these wells drilled into the ground. As you can see here, where I'm at up in the Nebraska Sandhills, it's pretty dark blue, which is pretty deep saturated thickness within the aquifer. And then as you get into Texas in the high plains, you will see a decrease in your thickness of the saturated layer of the aquifer. And then the image on the right is also showing a net change in the aquifer depths over time. As you get darker blue, that's a positive recharge in the area. And then as you get to your darker reds, as you can see around the Lubbock and Amarillo regions, we're seeing a high loss within the aquifer due to this type of irrigation. We can also have diversity in our crops in the area. I know different areas of the U.S. are accustomed to and better suited for different crops. So around Lubbock, you'll see a lot of cotton and you'll see a lot of corn. Where I'm at up in Nebraska, I'll see corn, soybean, and then some types of hay production within our grasslands as well. And then when you get down into Kansas, you'll see more of your sorghum production, especially out in western Kansas. So crop diversity is important in order to hit our different markets, but then also to be able to match the correct plants with the climate that you're trying to grow them in. So feedlots are kind of an interesting example of this intersections of crops and livestock. So the concept of feedlots is much different than what we recognize feedlots as today. Feedlots originally developed within the Ohio River Valley, which is a pretty lush and green area of within the Corn Belt. This deep, fertile soil has historically been used for corn production since it was settled in the mid 1800s. What farmers originally did in those areas were have their fields fenced off, growing corn, and then after they would harvest the corn, they would rotate these cattle into these fields on stubble. Cattle are able to take in nutrients through the fall and winter on corn stalks. Cattle would eat, get their nutrients out of the ground that way, and then leave a whole lot of manure on the ground. Pigs would then follow behind the cattle after the cattle were rotated out. Pigs are known to eat not that good of food. In this case, it was a whole lot of cow manure. Pigs were able to root through that, get what they can out of that. And this system was then used because they understood that they could put on as much weight on these animals as possible. They were seeing high gains within their cattle after they were on corn, as well as having the pigs be able to break up some of the manure and still be able to gain weight. So they were getting three different commodities, corn, cows, and swine, off of the same field pretty efficiently. Nowadays, we see feedlots fencing in areas, not so much rotating cattle through stalks. Up here in the more northern Great Plains, you will see cattle on corn stalks during the wintertime, but there is no real rotation of cattle and swine on stalks like they used to have in the Ohio River Valley. As cattle began moving west, as farming became more intensive. Because of this, animals being moved further away from croplands, this results in needing to transport animals from grasslands to these croplands, which then ended up having animals just be transported to large holding areas that they can be then fed grains to be able to still reap the benefits of taking in corn over the winter. As we move out of feedlots, we see this further distance between livestock and cropping systems. Livestock species such as cattle, goats, and swine were originally brought to North America by European colonists. Horses and dogs were also used pretty extensively by the Spaniards as they moved west as well. And because of this, these industries often pushed ahead of agricultural development as they were moving east to west. Most livestock within this timeline within the United States were ran on a concept known as open range prior to the settlement and divvying up of land by the United States as well as the farming industry. Cattle drives were these historic routes taken by ranchers across the Great Plains to be able to make it up to the railheads in Kansas that were then shipped to stockyards across the Midwest and began this model of industrialized animal production. Because beforehand, most people weren't able to get beef from 2 states away. The cattle and livestock that you had around your town on your farms were the focus of the meat that you were eating. Now with this concept of industrialized animal production and moving livestock on railways to these larger population hubs, we're now seeing an increase in meat consumption within the United States. A lot of the cities within the Midwest and Great Plains region developed around these historic stockyards because these were booming economic areas of lots of trading and lots of jobs. So we're thinking Fort Worth, Chicago, Kansas City, and Omaha all developed because of their role within the stockyards. Here are some images of both past and present conditions within stockyards. Everybody knows about the Fort Worth stockyards. They're the historic stockyards within downtown Fort Worth that are now serving as a pretty pretty cool tourist attraction for people that are coming through the area. A lot of these areas, in the bottom left corner, you have the Omaha stockyards, and then on the right side of the screen, those are the Kansas City stockyards. A lot of these areas have since been leveled and turned into industrial parks for other reasons, as the cattle drives kind of left the area, and the need for the actual stockyards also dried up. An awful problem with the open range concept was this concept of overgrazing, in which animals that did not have fence lines were not really well contained at all times of the year, which led to overuse of certain areas. These overuse of areas led to like the diminishment of above ground plant matter, which then exposes our soil, which is then very threatened by wind erosion. This concept's probably been talked to you guys about by Professor Hayes, and it's a concept known as tragedy of the commons. This open range concept in which everybody's using a resource below its carrying capacity looks just fine. But as you quickly approach the carrying capacity of a landscape, everybody's scrambling to get their fair share, and all of a sudden that common resource is gone. That's exactly what was happening in the Great Plains with this overgrazing problem. Livestock operations are, for this purpose of this lecture and as far as definitions go, it's domesticated animals raised for commodities. So milk, meat, eggs, leather, etc. Within the U.S., cattle, sheep, and goats and swine are considered livestock, and then poultry are considered their own class. For this lecture, we'll focus mostly on the cattle side of things. Within our cattle operations, we can then kind of divvy that up into beef or dairy operations. And since we're kind of talking more about rangelands within the concept of this lecture, I'm going to focus a little bit more on the beef side of things. Within beef, you have cow-calf operations, you have stockers, you can have heifers. Feedlots are also within the beef cattle industry, in which you've got a lifespan of a steer goes from it's born as a calf on a cow-calf operation. It grows to be a yearling steer. It's then sent over to a stocker operation, in which they can gain more on grassland. And then for the final portion of its life, which is pretty quick in the grand span of things, it is then put on a feedlot, fed grain, gains weight at a rapid rate, and is then slaughtered for beef. Seed stock is the practice of growing bulls for their genetics and then being able to sell those genetics off to cow-calf operations. We're talking terminology within cattle operations. A cow is a bred female. Heifer is an unbred female. A bull is an intact male. A steer is a castrated male. Calf are young, not yet weaned animals, and that's generally while they're still suckling, so yes, not weaned. And then a yearling is a weaned calf, which is around a year old. So those are then turning into your stockers. Cows look different across the United States. A lot of these different breeds are bred for certain qualities, whether it's heat tolerance, gain, or other associated qualities with production. European cattle are the most common cattle within the United States. These are your Black Angus, your Herefords, your Red Angus, and so on and so forth within the beef cattle industry. Your Indian cattle are seen more down in Texas, southern Texas, where these cattle are a lot more heat tolerant than our European cattle. Up here, up in Nebraska, in the Great Plains, Central Great Plains, we have a lot of Black Angus as well as Hereford operations up here in the Sandhills. As we're talking about cattle breeds within the United States, I wanted to point out the top 5 cattle breeds in the U.S. are Black Angus, Charolais, Hereford, Simmental, and Red Angus. As you can see, all of these species are within that European or Bos Taurus cattle species. For the majority of their life, and for the majority of a lot of beef cattle operations in the United States, cattle are ran on rangelands, in which they spend the majority of their life out on grassland, intaking most of their nutrients through the naturally occurring grassland ecosystems that are already out here. Now, they are fed supplements and hay throughout the winter, but for the most part, a lot of these operations are taking advantage of the naturally occurring processes of grass production in order to feed their operations. Grazing allocation is a concept used to avoid the overgrazing or overuse of an area. This is also known as cross fencing, or using smaller sections within a field to move cattle around to make sure you have uniform use of the area. This can look very different across different operations, but the concept still remains the same. Cattle are not allowed to just sit and munch on one area all year long, because that would reduce the plants in one area, reduce the quality of that area, but then also you are wasting money by not allowing your operation to take advantage of those other areas that are growing grass for you. We do a lot of these grazing allocation calculations through the concept of the animal unit. And the animal unit, or AU, is a 1,000-pound cow with or without a calf who is eating roughly 3% of her body weight per day. You're able to calculate this to then give you pounds of forage needed by an animal, that then you can then calculate to how many animals can you stock within a certain area, because you know how many pounds of forage your land is then creating. Not all livestock are a 1,000-pound cow with or without a calf eating roughly 3% of her body weight in a day. So we need to know that the animal unit is not an end-all be-all concept for grazing allocation. We can adjust that animal unit to the different classes of our livestock based on how much they are eating. So then we can figure out how many of a certain class of livestock can we fit within our landscape. So moving on from livestock, we can see this start to talk a little bit about the timber industry. Timber industry was kind of occurring about the same time as the westward expansion of livestock across the United States. The timber industry really sprung from the old growth forest of the northeastern United States. When European colonists landed on the East Coast, they saw this seemingly endless supply of timber to be used for shipbuilding and empire expansion. Because of this ended up in a rapid deforesting event of the East Coast and a large overuse of that resource. Deforestation does have its negative effects on the landscape. In this picture, you have a clear-cut area. Because of that, you've got nothing holding the soil down, and with such steep slopes, a heavy rainstorm will end up leading to a mudslide within this area. This map shows a rough estimate of where virgin or untouched by European colonizers the forest lands of the United States were. As you can see here, most of the eastern third of the United States was heavily forested. As you can see now, moving ahead, we see this rapid decrease within our treed areas. A lot of an opening up of the Ohio River Valley, in which we're now seeing the start of the corn belt, so to speak, of the United States. Agriculture is replacing forests in these deeply fertile and productive areas. Modern forestry management is done in a way just like modern crop management or livestock management is done in a way that we can still sustainably use these resources without doing too much damage to them. Arboriculture is the care of individual trees, and this is often done in urban forestry. So urban forestry is not so much the timber industry as much as it is more landscape management within a city. So you'll see people cutting trees around power lines or trees that are uprooting sidewalks. This is anything that you're doing to trees. An individual tree that's causing a problem within an urban landscape often falls within this arboriculture terminology. Agroforestry is then the incorporation of trees into the agricultural landscape, but not so much using those trees as a commodity. You're putting them into your practice as a way of stopping the wind or creating a living barn. Silviculture is the management of stands of trees for lumber. So this is what we're thinking about as far as our timber industry would most likely fall within your silviculture term. Then silvopasture is a combination of silviculture, but then also incorporating grazing into forestry management. This is often done a lot of times under nut and fruit production, which cattle are able to graze the low-lying grasses as well as anything falling from these trees. And then they're still able to harvest those trees for lumber. Agroforestry really much developed within the Great Plains as the concept of windbreaks. Back in the 1930s and 40s, the Great Plains Shelter Belt Project was initiated by the Soil Conservation Service and the U.S. Forest Service to begin planting trees across the Great Plains in order for producers to be able to minimize wind erosion on their fields, as well as create a living fence or a living barn for animals to hunker down within the winter time, or in the case of where I'm at now, spring snowstorms during calving season, to be able to get animals out of the wind and be able to calve safely was a really big need within this area. So trees were originally planted in this area for that reason. Silviculture can involve the clear cutting as described before, but then we can also see different systems in place, such as different cropping systems or different tillage systems in use to be able to conserve the area a little bit better. So we can see patch cuts or shelter wood as being used to allow an older tree to basically serve as a protector of younger saplings underneath it to then grow. Then once those saplings get to a certain age, you're able then to cut that older tree, and those saplings will then serve as the shelter wood for those younger trees underneath it. Like I said before, silvopasture is this incorporation of grazing into timber management. And this is a lot of times coming out underneath the fruit, nut, and timber trees that are used. Cattle are grazing this understory or browse or anything that's falling off of those trees in order to gain weight. But then we can also manage these trees for other purposes other than just cover for cattle. So moving on from cropping, livestock, and timber production, we can now start talking about the natural resources we're trying to conserve within these areas. So to begin, we just need to talk a little bit about what is soil. Soil is made up of two components, abiotic or non-living mineral components, as well as biotic, which is living or previously alive components. The arrangement of these two types of particles, as well as the space within that, is what creates soil. Soil performs essential ecosystem services by allowing us to grow crops out of it, allows us to harvest the timber, allows us to have parks. That's where the grass needs to grow in something after all. Soil performs a lot of essential ecosystem services for humans. The concept or the basic building block of soil is called the pedon. It's this three-dimensional arrangement of soil that is formed from the bottom up, coming up from bedrock. So bedrock is then weathered down and loosened, and that becomes the sea horizon of soil. As this soil is then allowed to get organic matter or biotic components built into it, so whether that's microorganisms or organisms dying and then decomposing into that soil, those allow us to build our other horizons within soil and create the soil pedon. Within the abiotic component of soil, you have three classifications of particles types. This is mostly based on their size. So you have sand, silt, and clay. Sand is our largest particle. I know sand, when you look at it, doesn't seem that large, but you can still feel the grit. As you go down, you then run into silt, this intermediate sized particle, and then clay is the smallest particle. It can pack in the tightest. It has the least amount of pore space in between itself. That's why clay can feel sticky, because it can pack itself in so tight. The mixture of those three classifications then gives us a soil texture class for the area. As soil gets weathered down due to water and wind erosion, we can end up with pretty drastic results of erosion in a field, which can then interfere with day-to-day operations. Erosion really begins to start with just the gradual transport of these little particles, but over time this can kind of have a snowball effect in which water and wind will begin to carry away more and more of your soil to the point in which you're losing tons of soil per acre per year. In Lubbock, Texas, this is a common sight right around the springtime and sometimes in the late fall, in which you've got these massive windstorms picking up and carrying soil in the form of dust, right? Which can then black out the sky. It's not good because that's tons of soil up in the air that farmers are losing per acre per year, as well as there's health effects associated with that, with air quality decreases and whatnot. So some of these indicators of poor soil health, it really comes down to erosion. Water erosion and wind erosion are the two major types of erosion modalities. Water is when there's a detachment of a soil particle from the surface due to raindrops striking the surface. These little particles are detached and then picked up as sediment within that runoff and taken somewhere and deposited somewhere else. Wind erosion really comes down to the speed or velocity of that wind. As wind velocity increases, it will pick larger and larger particles up, into which you have a suspended particle way up in the air causing a dust cloud. And then with lower wind velocities, you might see just this creep of sand grains across the ground. The beginnings of water erosion starts with interrill erosion, which is this concept of raindrops striking the surface, detaching soil particles. And the concept really comes down to the thought of a uniform sheet of soil moving down the landscape. Now, it's not really happening because at the point when we can see it happen, it then becomes rill erosion, in which these little channels are formed due to areas of the least resistance that water is going to follow as it leads down the hill. As rill erosion increases, it will turn into a gully. The difference between rill and gully erosion is which you cannot cross a gully with standard equipment, and a lot of remediation of that field is going to need to happen in order for you to be able to cross that and for that gully to not form immediately after you pack it full of soil. Stream channel erosion is when everything runs downhill into the stream, and then all that sediment from your field creates oxbow lakes within the stream and changes the curvature of the stream. So another concept of indicators of poor soil health includes compaction. So erosion is when you're losing soil. Compaction is when our soil is too dense for our crops to be able to grow. Plants take up water through their roots within the ground, and because of this, the soil needs to allow for those roots to be able to grow through the soil, but also needs to be dense enough for that water to be held within that soil profile for those plants. So we call this like a kind of a Goldilocks zone. Not too much, not too little, just right. Depending on your class of particles, so sand, silt, and clay, you have different levels of too compact versus too loose for both soil and root development. Saturation is which you've got water no longer being held by your soil profile. This is after a heavy rainstorm in which you've got so much water in that soil profile, a lot of that water will just end up draining through the soil. Field capacity is the middle of our Goldilocks zone, right? It's this just right, in which we've got moisture within our soil profile without it falling out of the soil profile, but this still allows for roots to be able to grow into it. And then this permanent wilting point is which we have no water within our profile and because of that, nothing will even drain through the profile itself. Compaction and porosity are two inverse concepts in which we've got compaction on one hand being the how dense things are packed in together, and with porosity being how open are our pores between the soil. Those pores are important because that is not only air for our microorganisms, but that's also areas where plant roots can grow into, as well as areas where water can be stored. Excessive force from heavy equipment breaks down soil aggregates, so our larger soil particles, that will be broken down, close our pore sizes, and increase the compaction of soil. Because of this, we have less space within that soil profile to actually be able to hold water. Compaction over time can adjust our water availability for plants, in which all of a sudden we can no longer have field capacity soil that's holding water. That soil might be so tight that water can't even penetrate the soil, and that's where we have areas with a lot of runoff after rain events. These limits of available water to field capacity definitely change depending on your soil texture class. So an area with sand can receive different levels of compaction than clay soils. And because of that, we need to make sure we have an understanding of what soils are beneath our operations before we go about driving heavy equipment across of them. So we can make some management decisions for improving our soil health to reduce not only our wind and water erosion, but also reduce compaction. A couple of these two practices listed below are mostly used to combat our erosion. Windbreaks, as discussed before, are used to slow the blowing of wind across an area. So these breaks are primarily planted perpendicular to the prevalent wind direction and slows the wind so that area in the field is not seeing as much extreme wind activity on the soil surface. Grassing our waterways is a practice used to not only slow the downhill runoff or real erosion from rain events, but also to help trap pesticide runoff or fertilizer runoff from fields in order to keep the waterway cleaner. In areas where we have a lot of agriculture occurring, we also tend to see a lot of polluted waterways due to runoff from pesticides and fertilizers. Grass barriers and prairie strips are two other practices used within the fields of trying to minimize wind and water erosion as well. Grass barriers are usually characterized by stiff, warm season grasses, stiff-stemmed, I should say, warm season grasses, and prairie strips are used more of a high diversity mix of plants with a lot of wildflowers in there for pollinator habitat. When we're talking compaction, it's important to understand the soil bulk density of your area, and this is a calculation used by taking a measurement of soil within a known volume, weighing it, air drying it, then weighing it again. So then you have a density of soil within that area, within that unit volume, but then you also have a measurement of how much water you've got in your soil as well. This also changes between your three different texture classes. So you'll see there in table 1, you do have different bulk densities that allow for plant growth, and then you get to bulk densities that restrict your root growth. And those are each different based on your different soil texture classes. One of the biggest recommendations for compact or mitigating compaction within soils is just avoiding heavy equipment driving in a repeated use through an area or driving within saturated areas. So what they like to say is tell farmers to stay out of fields for at least a day after a really hard rain to allow for that soil to soak in that water and to keep you from getting too compacted too quick. Two other alternative practices for mitigating compaction in a field is planting a biodrill. And a biodrill is just a plant that has a pretty starchy root to it that will then kind of open up the soil. A lot of times this is done in cover cropping scenarios with radishes in order to break up a compacted soil surface. They will plant radishes in which that radish root will then open up the soil, break up that compaction around itself, and then they get rid of those radishes and plant something more profitable within that field. Plowing is a short-term solution to a long-term problem of compaction. People will plow or till an area in order to break up the soil surface. That's good, but repeated plowing only goes so far because your plow only runs so deep, right? After a while of running a plow over an area with a lot of repetition, you'll have your nice broken up area, but you'll end up with a plow pan, which is this area right below your plow that gets compacted all heck as you drive over that area repeated times. Just like understanding the differences in our soils to cropping practices and knowing when to avoid driving heavy equipment over them to avoid compaction, or understanding what practices we want to do to minimize erosion for agriculture, for more of our cropping practices, it's important to understand the different adaptations within plants that are tolerant or intolerant of grazing. Grasses have a really interesting scenario in which they grew and evolved to tolerate a certain level of grazing. And when I say certain level of grazing, that means not overgrazing, but grazing at a certain point within their annual life cycle. Grasses start out the year in a vegetative phase or growing phase. So they'll keep their growing points, the areas on them that are constantly dividing and making new grass leaves. That growing point is at the just about right at the ground. And because of this, we're able to graze cattle over grass, and grass can still grow back just fine when they're not in a reproductive phase of their life. Because we keep taking these this new growth without it affecting that growing point is also what allows you to be able to mow your yard without killing all your grass. However, once grasses reach a certain point of the year and they want to begin their reproductive phase of their annual life cycle, then you need to start thinking about moving animals off of that, because that growing point will then be removed by animals or by mowing. That will then take another year until we see any actual regrowth from new tillers the next spring. And being able to understand this responses to grazing will allow for producers to be able to better understand and improve both the plant and soil health of the land they're working on, but also be able to make better profitable decisions for their operations. And when I say annual life cycle on the previous slide, I do not mean annual plants as in plants that start from seed in the spring and are usually done with their whole life by the fall. An annual life cycle of a plant is seen in these perennial plants, in which a perennial plant will grow in the spring, put on leafy green matter to allow for photosynthesis. At some point in that growing season, they'll put on reproductive parts through stems and seeds, begin its reproduction phase, and then by the time the late fall rolls around, that plant then reverts back to gaining as much carbon as it can through photosynthesis and putting that all towards its root production. This root production is what allows these plants to be able to grow so efficiently year in and year out. Annuals really are more of on a boom bust life cycle, whereas perennials are kind of the slow and steady wins the race. Understanding the plant and animal dynamic of grazing animals on a landscape allows for us to have healthy rangelands. Healthy rangelands are really important not only for producers, but they can also create excellent habitat for wildlife, as well as the same ecosystem services we talk about from soil. This picture here on the right is a prairie chicken, a male, during the mating season, in which they will dance around on the lek attempting to attract females, and it will blow up those bright orange air sacs to basically display to the females that they are worth mating with. Right now, it's the up here in Nebraska. I'm in the middle of prairie chicken lekking season, and the lek is this area where the males will all gather and begin their dance in order to attract the females. So it's a really cool sight. If you guys in your free time look up prairie chicken lek, LEK, I would say that's worth looking into if any of you guys are interested in learning more about wildlife on rangelands. Rangelands across the United States basically are from the Mississippi River west. So forest lands are more on the eastern side of the U.S. And then we get into rangelands on the western half. For this conversation, I'm going to be talking about grasslands, and grasslands are these rangelands that are primarily dominated by grasses. Within that, we have a lot of different species of grasses, and the dominant species within those are oftentimes categorizing our different styles of grasslands. So as we move east to west across this precipitation gradient, we go from a tall grass to a mixed grass to a short grass prairie, stretching from the provinces up in Canada all the way down into Texas. Tallgrass prairie is seen historically in states such as Iowa and Minnesota, but this type of prairie has largely been replaced by croplands. We still see remnant tallgrass prairie within Nebraska, South Dakota, but some of the largest remnant intact tallgrass prairies are going to be seen in the Flint Hills in Kansas. And these are the types of grasses that will grow taller than a pickup truck driving through a field. Our shortgrass prairies out in the west, kind of this high plains area, areas receiving much less precipitation per year, are categorized by, what have you guessed it, short grasses. So buffalo grass and blue gum are mostly the predominant species of these areas, in which you most likely won't find grasses much higher than your shin walking through an area. We have a lot of different invasive species within rangelands that are needing to be managed in order to allow for the continued growth of desirable plants for cattle and wildlife. You have noxious weeds that are needing sprayed every year, such as the musk thistle in the upper left-hand corner. You have problems such as cheatgrass in the lower left corner that are wreaking havoc across the Great Basin and northern Great Plains as an annual grass that's not really worth much in forage, that is quickly taking over areas and effectively changing the fire cycle by becoming a really flammable little guy really quick in an area that hasn't actually seen fire as frequent as it would like. You also have invasion of woody species in these areas. So areas that are not seeing heavy fire or heavy grazing will eventually be overgrown by woody species. These woodier species can outcompete grasses in the absence of fire or grazing. And because of this, we'll see hotter wildfires in areas that are much more non-resilient to wildfire, because these fires will burn through so much hotter when they do go through areas of high invasive woody species. Aerial imagery really shows us some of these pretty grim pictures of woody encroachment within our grasslands. A lot of this stems from eastern red cedar up here in the northern Great Plains, as well as the eastern Great Plains, such as eastern Oklahoma and eastern Texas. And then mesquite, or honey mesquite, I should be specific, is the predominant woody invader of grasslands across Texas. As these trees begin to invade areas, we're now seeing a stark shift in habitat type. Not only is this meaning less grass for cattle or livestock producers, but this is also effectively a different habitat than the wildlife that we're used to that area can be suitable with, right? We're seeing wildlife populations, be it on the decline, are more grassland tolerant wildlife populations are on the decline in areas that are seeing heavy woody encroachment. That's probably a good thing for the more woodland tolerant varieties of wildlife. But when we start talking about concepts such as the Endangered Species Act, it's very important for us resource managers to understand that just because we have more of one type of animal doesn't mean the lack of the other one makes it any better for the ecosystem. Earlier when I was talking about fire intervals, some of the tools that we use to better manage our grasslands is through intentionally setting fires. So prescribed burning is one of those tools. I know it's hard to wrap your mind around, but sometimes you need to light a fire in order to make sure you don't have a wildfire pop up. These prescribed burns are oftentimes done to reduce our fine fuels, so our grasses in an area. And by doing that, it keeps our fuel loads down. So in the case of a dry summer or a dry fall, when we have thunderstorms roll through and lightning strikes an area, if we don't have as much standing dead grass from last winter around, that will limit our possibilities of a wildfire getting out of control and racing towards human structures. Herbicide application is also done in these areas as well, not so much from a tractor with two big wing arm sprayers or a crop duster going over an entire area. This is more spot application through a pump jug on a backpack sprayer with an individual going around and spot spraying noxious weeds. A lot of these pesticides will kill any plant that they touch out here in the field, and since we're not really dealing with Roundup resistant plants out here, it's important to not just coat an entire area with herbicide, because otherwise you're not going to have anything left for habitat or livestock. Alongside prescribed burning and herbicide application, we can also do mechanical removal. This is more oftentimes done with our woody encroachment. So prescribed burning is usually done more to reduce your fine fuel loads in an area. Now, a lot of times our prescribed burns do not get hot enough to actually kill these trees out here. So we need to resort to skid steers with shredder attachments to actually cut down those trees. And when they can take down trees that are about 60 feet up in the air in a matter of 30 seconds and turn it to a pile of sawdust, that's a pretty impressive feat to see. One of the biggest things that we can do in order to manage healthy rangelands is through appropriate livestock grazing. And that's not just coming down to appropriate stocking rates, but that's also coming down to appropriate class of livestock. Understanding what do we have out here and understanding what our livestock prefer to eat. By matching those two things, you're going to have a lot easier time managing your rangeland in a healthy way and not fighting an uphill battle most of the way. A lot of times you'll see cattle producers trying to raise cattle on down in the Texas Hill Country on areas that are much better suited for our browsing goats and sheep, because we're not seeing as much grass production. We're seeing a lot steeper slopes. You got a lot of trees, just not really good cattle habitat, but a lot better suited for goats and sheep. After choosing the appropriate class of livestock, it also brings us back to our grazing calculations and being able to rotate animals through pastures. This graphic here also shows a vegetable filter strip, which is seen within our cropping systems as a way of minimizing water erosion and keeping harmful particles outside of our streams, especially if it's coming from a downhill runoff from the tanks and corrals where we're holding animals. A lot of times fecal matter getting into the stream allows for algal blooms as well as other harmful particles within our water. And I guess with that, I wanted to wrap up real quick by giving a shameless plug for one of the clubs over in the NRM department, which is the student chapter of the Society for Range Management at Tech, or TTU SRM. So if any of these concepts from today's lecture is interesting to you and you want to get involved within range sciences and understand a little bit more about range management, there is a club for you within Goddard. This club does have competitive teams such as the Plant ID or the undergraduate range management exam. SRM is a professional society for people who are in range management. I was just up in Boise, Idaho at the National SRM, in which I was able to meet up with everybody from TTU SRM. So if any of that is interesting to you guys, be sure to contact Steve and Ida for more information. As well as also getting involved with range management, there's the department of NRM does have a full staff of range management faculty. So please feel free to reach out to any of them if you have any questions as far as wanting to get more involved in range management or to just take your first class in Intro to Range Management. I wanted to thank you guys for listening in today, and I wanted to thank Professor Hayes for allowing me to come and give this talk. I've given some iteration of crops, soil, and range management, I think, for the past 3 semesters now, 3 or 4, and I've enjoyed being able to come and talk to you guys every time. So thank you for sitting down. If you want to reach out to me, I put my UNL email on here. I'd love to chat with anybody about anything concerning range management, and I can help point you in the correct resource either at Texas Tech, or if you are interested in coming up to Nebraska and seeing the Nebraska Sandhills, the shameless plug is we are hiring for ranch interns across the state. So if ranch management or range conservation is something that you guys are interested in pursuing, feel free to reach out to me and I can see if we can find a spot for you up here. So thank you for listening and have a good day.